Hey guys, and welcome to your last note video of this unit. So the first thing I want you to do is get that distance formula written down in that box just so that you have it going forward for today. Okay, you're going to need that for a lot of the problems that we do. So let's start with number one. Now, number one, it's going to be kind of interesting because what I'm going to show you is actually how the distance formula and the Pythagorean theorem are related. So, a certain helicopter. So I'm going to start with Minneapolis first. So I have Minneapolis here. And I have to go 225 miles to the east, and I have to go 175 miles to the south. Okay, so this is how far, if I were to go corner to corner, how I would get to Chicago. Now, when we're taking a helicopter, we don't have to go straight across and straight down. Helicopters have the option of cutting across, like so. Okay, so I use 225 to represent how many I'm going over and 175 to represent how many I'm going down. So now we want to calculate this value. Well, actually, it just so happens that this right here is a right angle. So this actually is a Pythagorean theorem word problem. So let's go ahead and calculate that out. So what it would be is we're looking for our c squared because this is our hypotenuse. So we have c squared is equal to 225 squared plus 175 squared. Now, in order to do this, we need to take the square root of both sides. Now I'm going to take a second and show you something kind of neat. So let's call Minneapolis the point 0, 0. Let's call Chicago the point 225, negative 175. And I got that because we went right 225 and down down 175. Now if you were to plug that into the distance formula, just trust me on this, you would end up getting this. Negative plus positive. So you end up getting the same thing underneath the radical. So that's kind of what we're doing today. So ultimately, if you needed to, you could technically use the Pythagorean theorem on a lot of these problems. So I'll try and help you distinguish which is good to use when. So let's continue using the Pythagorean theorem on this one right here. So we get that c is equal to the square root of 225 squared, which is 50,625. And then 175 squared, which is 30,625. Okay, so when you add those together, you end up getting the square root of 81,250 miles. Now, normally I would have you simplify the radical, but just for the sake of right now, I'm just going to write that as a decimal. So that's going to give me about 285 miles. So if we were to completely cut across from Minneapolis to Chicago, it would be about 285 miles as opposed to going all the way around this way. Okay, that would be a lot more. So the word problems you're going to be doing on your homework are very, very, very similar to these. So what I want you to do is be checking with your homework or your note sheet while you do your homework because it'll help you out a lot. So let's take a look at this golf ball. So this one does require us to use the distance formula. So here's my golf hole. I'm going to make my golf hole the point 0, 0. Okay, now it tells us in the problem that Tracy's golf ball is 20 feet short and 8 feet to the right of the cup. So I'm going to say that it's 8 feet to the right and that it's 20 feet short. Okay, but then she's going to shoot the ball and it's going to land 2 feet to the left and then it's going to land 3 feet beyond. Okay, so we're trying to figure out how far it is from here to here. So this is the point 0, 0. This point right here, I'm going right 8. So right is always positive, left is always negative. So I'm going right 8, down is negative, so I'm going down 20. So that's the coordinate point of this point over here is 8, negative 20. Now over here, we're going left 2 and up 3. Okay, so that's our distance for there. Now we're going to plug this into the distance formula. So again, that's why it's important you have that written down. So I'm going to call this x1, y1, x2, y2. So I have y2 minus, x2 minus x1 squared plus y2 minus y1. So the formula says minus, so you're always subtracting. The only time you don't subtract is a case like this, when you have minus a minus and you need to change that to be plus plus. So now negative 2 minus 8 is negative 10 squared. And then 3 plus 20 is 23 squared. So now we have this. Let's go ahead and write that out some more. So 10 squared is 100. 23 squared is 529. So let's go ahead and add those two together and we get 629. And I'm just going to tell you for the sake of time that this is a fully simplified radical. My biggest concern today is, can you get the problem set up? If you don't simplify the radical 100% correctly, then I'm not as concerned, because right now I just want you getting it set up. We'll worry about simplifying it correctly tomorrow. So something you might want to do while you're working is have me check your setup so you don't go too far without knowing if it's right or not. Okay, so next, let's go ahead and take a look at that next word problem. Okay, so college campus. So I'm going to call the university library the point 0, 0. So I'm going to call this undergraduate place the point 0, 0. So she has her first class in Rhodes Hall and her second hall in Fulton Lab. How far does she have to walk between her first and her second classes? So now we're trying to figure out this distance right here. Okay, so I know that she's going to have to go over 1/4 of a mile from the undergrad library. She's going left 1/4. So that's negative, but she's not going down any. So my y is going to stay at 0 because she's not going up or down any. Now, to get to the Fulton Lab, she's from there, from the library, is going over 1/8. And she's going down -3/8. Okay, so this is a little bit of a challenging problem, okay? So the biggest thing is just to figure out those coordinate points. So I always take the center one and make that 0, 0, and then I go left or right. If it's left, it's negative. If it's right, it's positive. So now we're going to plug this into the distance formula. So let's go ahead and make this x1, y1, x2, y2. Let's plug it into that distance formula. So here we're going to have 1/8 minus a -1/4. Well, that's going to become plus plus. -3/8 minus 0. To save you the headache of doing fractions, okay, I'm not going to expect fractions to do the homework. I will add those together for you, and you end up getting 3/8 squared plus a -3/8 squared. So when you add those two together, you end up getting 9/64 plus 9/64, which is the same as 18/64. So now what you'll notice is I simplified that into two radicals. And you know why? Because I know the square root of 64. I know the square root of 64 is 8. So I'm just saving myself some time. So left on top is the square root of 18. Well, let's see if we can break that down a little bit. Square root of 18 is 9 and 2, 3 and 3. So I can pull out a pair of 3's. So I'm left with 3, radical 2 on top, and 8 on the bottom. Last thing I want to do is label it. So 3 square root of 2 over 8 miles. That's how far she had to walk. So again, you're going to be doing similar problems based on your notes. So keep the note sheet out while you're doing this. Let's take a look at number 4. So we just need to label these sides. So I'm going to say A is point -3, 4. B is 0.52. And C is point -1, -5. Okay, so we want to calculate the distance of each of these sides. I'm going to start out by calculating the first one, and then I want you to calculate the rest of them. So I'm going to calculate the side AB. Okay, so I'm going to calculate the distance between this point and this point, just like I was doing yesterday. So I'm going to do x2 minus x1, so 5 minus a -3 becomes plus plus, y2 minus y1, and square it. So I'm going to keep simplifying, so I get 8 squared plus a -2 squared. It's good to keep those in parentheses. So then you get 64 plus 4. So that's going to give us square root of 68 for A. Okay? So what I want you to do now is I want you to calculate the distance between these 2 points and the distance between these 2 points. And what I want you to tell me is if all the sides are the same, or if 2 of the sides are the same, or if 3 of the sides are the same. Okay, so I just want you to calculate those 2 sides out for me. Next, that just keeps popping up, doesn't it? Next, let's talk about another mini golf problem just to practice. So again, I'm going to start by drawing the hole itself right here. So I'm going to go ahead and set up the drawing for you. So just like the previous problem, I've set this one up. Okay, so we went left 3 and we were up too far for 12, so I gave the point negative 312. Here we went down too far with 2 and over 1. So let's go ahead and we are going to type or put this into the distance formula. So then what I get here is I'm going to get, oh, come on, y or x1 minus x2. Now when you subtract a negative, it becomes plus plus. Y2 minus Y1, and then you're going to square it. So what I want you to do is finish simplifying this problem for me. Okay, so I want you to completely simplify this out, and remember to simplify the radical at the end. So I want you to finish this part up for me. Next, let's take a look at this one, Mr. Cush, Mr. Berg, and Mr. Miller. So what I'm going to do first, so why don't you take a second, pause this video, and read through the word problem yourself. So go ahead and pause it. Okay, so I'm going to put Mr. Berg right here. Mr. Berg is going to be at the point 0, 0. So let's see where Mr. Cush is. Mr. Cush is standing 7 feet to the right, so I'm going to go over 7 feet, which is going to be about right there. And then he's standing 3 feet in front of, so I'm going to go up 3. So you're going to think of to the right as and to the left as on the X and in front of as on the Y. So we're going to go ahead here, and this point is going to be Mr. Cush. And he's at the point 7, 3. So now we're going to find Mr. Miller. Mr. Miller is standing 6 feet to the right, and he's also standing 8 feet in front of. So this point right here is Mr. Miller. So if we were to write out his coordinate point, Mr. Miller would be at -6 because we went to the left, and +8. So now we're going to go ahead and calculate this out. So using those points, we want to find the distance between Mr. Cush and Mr. Miller. So we're going to take x2 minus x1, again when you subtract a negative it becomes a positive, plus y2 minus y1 and square it. So then what we end up getting is 13 squared plus a -5 squared. That's going to give us the square root of 169 plus 25, which is equal to the square root of 194. Now normally we check through and see if we could simplify this down, but we can't, so we're just going to label it feet, and that is your final answer. So again, I'm talking through some of these word problems really quickly, so if you need help during your homework, please feel free to ask myself or Caleb. I'm going to do one more, and then I'm going to have you try number 8, because number 8 is very similar to number 9. So let's go ahead and take a look at this. Miss Johnson decided to walk to school today. How far is she from her home after walking 4 miles east and then 6 miles south? So here's her house right here. We're going to call this Miss Johnson's house. So Miss Johnson's house. I'm going to give her house, since she's starting there, the point 0, 0. She walks 4 miles east. So if you were to look at a compass, I was always taught to look at it as never eat soggy Wheaties, north, east, south, and west. So she's walking 4 miles east and then 6 miles south. So this is actually could also be a Pythagorean theorem problem. You could use the Pythagorean theorem to calculate this C value, or you could use the distance formula. And this would be the point 4, -6, because we went over right 4 and down 6. So let's just use the distance formula for practice. So we have 0 minus 4 squared plus 0 minus a -6. That's going to become plus plus. Next, we have -4 squared plus 6 squared, which gives us 16 plus 36. And that's going to give us the square root of 52. So we want to simplify down that radical. We get 4 and 13. 4 breaks down to 2 and 2, so we're going to take out a pair of 2's, and we're left with 2 radical 13. And we want to see what our label was, which is miles. So if she were to cut across, she would walk 2 square root of 13 miles. So you're going to do the same thing for Mr. Peshman over here. Okay, so you're going to make his house 0, 0. And then you're going to see how much he's walking to the west. Now, west is to the right and north is up. So you're going to have to figure that out, okay? And then go ahead and show me your completed note sheet when you're done. Again, this is tough stuff. Be confident. You can do it. I'll help you out. Come show me your note sheet when you're done. Thank you.